Standard 8 Mathematics, Chapter 15, Area, Module 1. Let us first understand what is the definition of area. In geometry, area can be defined as the space occupied by a flat shape or the surface of an object. The area of a figure is a number of unit squares that covers the surface of a closed figure. Area is measured in square units such as square centimeters, square feet, square inches, etc. Area formulas of basic geometric figures. We have already studied these formulas. Let us revise them. So the first one is area of a square is equal to side squared. Second one, area of a rectangle is equal to length into breadth. Then area of a right angle triangle is equal to half into product of sides that makes the right angle. Fourth, area of a triangle is equal to half into base into height. First, let us study area of a parallelogram. Here in the given figure, A, B, C, D is a parallelogram and AE is perpendicular to BC. So AE will be the height of the parallelogram. So the formula to find area of a parallelogram is base into height. Let us solve sum of practice set 15.1, which says question 1. If base of a parallelogram is 18 centimeters and its height is 11 centimeters, find its area. Let us find a solution. We'll use the formula of area of a parallelogram is equal to base into height. By substituting the values of base and height, that is base is 18 centimeters, height is 11 centimeters. So 18 into 11 will give you 198 centimeters square. Question number 2. If area of a parallelogram is 29.6 square centimeters and its base is 8 centimeters, find its height. Let us start with the solution. In this case, area of a parallelogram is already given, that is 29.6 square centimeters. We'll use the formula area of a parallelogram is equal to base into height, and as we know, the base is equal to 8 centimeters as mentioned in the question. So by substituting the values, area is 29.6 is equal to 8 into height. We need to find the value of h. So dividing both the sides by 8, we'll get h is equal to 29.6 upon 8, which will give you 3.7 centimeters. Therefore, height of this parallelogram is 3.7 centimeters. Question 3. Area of a parallelogram is 83.2 square centimeters. If its height is 6.4 centimeters, find the length of its base. We'll use the formula of area of a parallelogram, that is base into height. Substituting the values, as area of parallelogram is 83.2 centimeters, that is mentioned in the question. Base we have to find out, so keeping the base as b, and height is given as 6.4 centimeters. So now dividing both the sides by 6.4, we'll get 83.2 divided by 4, which is 13. Therefore, the base of the parallelogram is 13 centimeters. Next, we'll see area of a rhombus. In the given figure, if you see A, B, C, D is a rhombus. And in this rhombus, AC and BD are the diagonals of the rhombus. One of the very important property of a rhombus that you need to remember is all of the sides of a rhombus are equal and the diagonals of a rhombus are not equal. So the formula for area of a rhombus is half into product of the lengths of the diagonals. Keeping the formula in mind, let us start with practice set 15.2, question number 1. So it says length of the diagonals of a rhombus are 15 centimeters and 24 centimeters. Find its area. So we'll use a formula. Area of a rhombus is half into product of the diagonals. So by product of the diagonals means you have to multiply the lengths of the diagonal. So substituting the value, that is the length of the diagonals, are 15 and 24. So that will be area for rhombus equal to half into 15 into 24, which will give you 180 square centimeters. Hence, we can say that area of the rhombus is 180 square centimeters. Question number 2. Length of the diagonals of a rhombus are 16.5 and 14.2 centimeters. Find its area. So again, we will use the formula. Area of a rhombus is equal to half into product of the diagonals. So in this question, the length of the two diagonals are given 16.5 and 14.2 centimeters. And substituting them, that is, we need to multiply them. Half into 16.5 into 14.2. And after multiplying them, we get 117.15 square centimeters. Hence, we can say that area of this rhombus is 117.15 square centimeters. Question 3. This is a little bit lengthy sum. It says, if perimeter of a rhombus is 100 centimeters and length of one diagonal is 48 centimeters, what is the area of the quadrilateral? So here the rhombus is given, and in this rhombus the perimeter of the rhombus is given as 100 centimeters and one diagonal is given as 48. Now they have asked you to find the area of this rhombus. So let us first find the side of the rhombus by using the perimeter formula. As it is mentioned in the question, perimeter of a rhombus is 100 centimeters and the formula for perimeter is 4 into side. Using this formula, we'll find out the side of the rhombus. So this becomes 4 into side is equal to 100. Dividing both the sides by 4, we get side is equal to 100 upon 4, or 100 divided by 4, which is 25 centimeters. That means each of this side of the rhombus is 25 centimeters. As we know, in a rhombus, all sides are equal. So here this is 25. Thus each side of a rhombus is equal to 25 centimeters. Now, diagonals of a rhombus, we know this is a property of a rhombus. So diagonal of a rhombus bisect each other at 90 degrees. That means they are perpendicular bisectors. So if you see the angle formed here at O will be a 90 degree angle or right angle. So AO and OC, as length of this entire diagonal is given, AC is 48, then AO and OC will be half of 48, that is 24. That means this length from here to here, AO, is 24 centimeters. Now if you look at triangle AOB, we apply Pythagoras theorem, that is AO square plus OB square will be equal to AB square. Substituting the values of AO and AB, so AO is 24, so this becomes 24 square, and AB is 25, so this becomes 25 square. Then OB square will be equal to 625, that is square of 25, minus 576, that is square of 24. So 625 minus 576 will give you 49. And now if you take the square root on both the sides, you will get OB is equal to 7. Now since OB is 7, DO will also be 7. So since DO is also 7, or you can say DB, that is the second diagonal, will be 2 times OB. That means these two lengths are equal, will be equal. So length of DB will be equal to 14 centimeters. Now we know the lengths of both the diagonals. As we know, length of the first diagonal is 48 centimeters and length of the second diagonal we have found out, which is 14 centimeters. Now we can use area of a rhombus formula, that is half into product of the diagonals. Substituting the values, this will be half into 14 into 48. Multiplying this, we get 336 square centimeters. Hence, we can say that the area of the rhombus with perimeter 100 centimeters and length of the diagonals 48 and 14 is 336 square centimeters. Let us do with the fourth sum. So the fourth sum says the length of a diagonal of a rhombus is 30 centimeters and its area is 240 square centimeters, then we have to find its perimeter. Let us start with the solution. So before, in this question, if you notice, the length of one diagonal of this rhombus is given, which is 30, and the area of this rhombus is given, which is 240. And they have asked us to find out a perimeter. So in order to find out the perimeter, let us start with finding first the length of the second diagonal. So we'll say let the other diagonal be d centimeters. We'll use the formula area of a rhombus. So area of a rhombus is equal to half into product of diagonals. Substituting the values, area of a rhombus is 240 and the product of the diagonals will be 30 into d. So this becomes 240 is equal to half into 30 into d. Rearranging this equation to find out the value of d, so d is equal to 240 into 2 divided by 30. After solving this, simplifying it, we get it d to be 16. So AC, that is length of the first diagonal 30 centimeters given in the question, and DB, that is the second diagonal which we just now found out, and that is 16 centimeters. Now as we know, the diagonal of a rhombus bisect at a right angle. That means it forms a right angle or a 90-degree angle here at O. And now if you see in triangle AOB, we can use Pythagoras theorem. So by Pythagoras theorem, we get AO square plus OB square equal to AB square. So if you look carefully, if AC is 30, then length of AO will be half of 30. And as we all know, half of 30 is 15. So AO is 15 square. And now OB, if you see, DB is 16. So OB will be half of 16, which is 4. So OB, half of 16, which is 8. So OB will be 8 square. So 15 square plus 8 square will be equal to AB square. As we know, 15 square is 225 and square of 8 is 64. So 225 plus 64 will give you 289. And now when you take square root on both the sides, we get AB is equal to under root of 289, which is equal to 17 centimeters. So now we got length of AB or side of the rhombus to be 17 centimeters. We can use this now to find out the perimeter. The side of the rhombus is 17 centimeters and we'll use a formula for perimeter, that is 4 into side. So 4 into 17 will be equal to 68. Hence the perimeter of this rhombus is 68 centimeters. That's it in this video. We'll continue the remaining portion of this chapter in our next video. Thank you.